Hello students, welcome back to MKG Online Study, an e-learning platform. Imagine this, you are writing your very first FPGA design, everything looks perfect, the code compiles, simulation runs, no errors, life is good. Then your senior engineer looks at your code and says, why did you use equal to here? You reply because it works, and then he says, that's exactly the problem. Today, we are talking about one of the most misunderstood topics in Verilog, a tiny symbol that has destroyed thousands of simulations. The difference between equals and non-blocking assignment. And trust me, after today's video, you will never look at these symbols the same way again. Now, let's start with a simple question. Why does Verilog even have two assignment operators? Most programming languages have one. C has one, Java has one, Python has one. So why did Verilog decide? No, we need two. Because Verilog is not a programming language. It's a hardware description language. And hardware behaves differently than software. That's the secret. When software runs, instruction executes one after another. Line 1, then line 2, then line 3. Very simple, but Hardware doesn't wait. Hardware is impatient. Everything happens at the same time. Hardware works in parallel. Register update together, signal change together, flip-flop react together. This is why Verilog needs special assignment behavior because it's describing hardware, not writing instruction for a CPU. Let's meet our first operator, the good old equal sign. If A equals to B, this is called a blocking assignment. The name itself gives a clue. Blocking means stop, wait, finish this first. This is the blocking assignment. Then move forward. Think of it like a queue. Nobody moves until the current task finishes. Current statement finishes first. Then we can move towards the next statement. Till then, next statement waits. Sequential execution. Imagine you are standing in a college canteen. There is one cashier, 10 students, only one student can order at a time. Everyone else, wait, this is exactly how blocking's assignment behave. One statement finishes, then the next statement starts. Everything happens in order, simple, predictable, and sequential. Let's see an example. If A equals to 5 and B equals to A becomes 5 immediately. B equals to AC's updated value. B becomes 5. First line executes. Now A becomes 5. Then second line executes. B reads the updated value. So B also becomes 5. Easy, no surprises because updates happen immediately. Now, here is something important. Blocking assignment are not bad. Blocking assignment are not bad. Many beginners here always use non-blocking. That's wrong. Blocking assignment are extremely useful for combinational logic, temporary calculations, intermediate values, behavioral modeling. The real problem is using them where they don't belong. And that's where bugs begin. Non-blocking assignment. Now let's meet the second operator. A is less than equal to. A, A is less than equals to. Let B. This is called non-blocking assignment. And it behaves very differently. Instead of updating immediately, it schedule an update. Update is schedule. Do remember this. That sounds strange. So let's use an analogy. Imagine you are booking movie ticket online. You click reserve seat. The system respond. Request received or request accepted. But seat doesn't update instantly. The request gets processed. Then the final update happens. That's similar to non-blocking assignment. The assignment is accepted now. The update happens later. Let's look at this. A is less than equals to 5. B is less than equal to A. Most beginners say easy, both becomes 5. Actually, no, because neither update happens immediately. Both assignments are scheduled. Verilog first evaluates everything, then updates everything together. Mind blown. Good. That's exactly why this topic confuses so many students. Now let's connect this with the real world. Think about register when a clock edge arrives. Does register 1 update first, then register 2, then register 3? No, they all update together at exactly the same clock edge. And that's why non-blocking assignment exists. They model real register behavior. Then block back to video 5. You have remember clock? Why clock exists? We learned that clock synchronizes hardware. When the clock edge arrives, thousands of registers react together, not one by one, together. Non-blocking assignment capture that behavior perfectly. Now let's zoom out. CPUs, GPUs, FPGAs, AI accelerator, all of them rely on register. Million of registers, million of them. And those registers update simultaneously. That's why RTL engineers heavily use non-blocking assignment. Not because the language says so, because hardware says so. Let's compare blocking versus non-blocking. Blocking assignment, immediate update, sequential behavior, one statement at a time. Non-blocking assignment, scheduled update, simultaneous behavior, hardware friendly. One models a queue, the other models real register. That's the key difference. The famous bug. Now let's talk about a trap, a famous trap. You wrote always at the rate passage clock begin A equals to B, C equals to A and compiles perfectly. Simulation runs. No warnings, looks correct, but the hardware behavior may not match what you intended. Hardware intent may be wrong. And that's where engineers spend hours debugging all because one tiny symbol. So what does or what do professional RTL engineers do? Simple inside clocked logic, use non-blocking assignment. Because they model real register, because they behave perfectly, because they avoid many bugs. This isn't just a recommendation. It is a survival strategy. Now imagine two students trying to write on the same whiteboard simultaneously. Who wins? Depends on timing, depends on order, depends on luck. That's race condition. And race condition are exactly the kind of bugs RTL engineers hate. Good assignment practices help avoid them. Here is a rule, memorize it, write it down, put it on your wall. Clocked sequential logic, use non-blocking assignment. Combinational logic, often uses equal to that is blocking assignment. If you remember just this rule, you will avoid a huge number of beginners' mistakes. Today, we have learned blocking assignment, immediate update, non-blocking assignment, sequential behavior, combination logic, non-blocking assignment, schedule update, simultaneous register behavior, sequential logic. And most importantly, hardware determines choice. Hardware determines which one to use, not personal preference. And now here is a question. If always blocks describe behavior, then who describes connections? How do wires get values? Can hardware exist without an always block? Absolutely. And that's exactly what we are learning next. Continuous assignment. One of the most powerful and most misunderstood concept in Verilog. So if you don't want to miss it, hit subscribe, continue the RGPV HDL playlist, and let's building your HDL foundation from scratch. Because step by step, you are no longer learning code, you are learning how hardware thinks. So, dear students, do watch next video. It is about continuous assignment. If you like this video, hit the thumbs up button, that is like button, and share this video with your friends, and do subscribe the channel. If you subscribe, then you can watch the further videos and become an RTL or Verilog or HDL master. Thanks for watching.